Problem 16. Let f be the function given by f of x equals 3x ln x. On what interval or intervals is the graph of f concave up? So if I'm looking at concavity, I need to be able to make myself an f double prime chart. So the first thing that I am going to do is find f double prime. So this will be f and this will be g. I'll have to use a product rule. F prime is 3, g prime is 1 over x, and so my first derivative will be f prime times g, 3 ln x, plus f times g prime, 3x times 1 over x. If I reduce that, f prime will equal 3 ln x plus the x's cancel, so I'm just left with 3. And then my second derivative, the derivative of 3 ln x will be 3 over x, and the derivative of 3 is just 0. So this is my second derivative. I need to find my critical numbers. This second derivative would never equal 0, but it would be undefined at x equals 0. So if I make myself an f double prime chart, put 0 on it, and then my second derivative, if I plugged in a negative number, I'm going to get a negative value for my second derivative, and if I plug in a positive value, I'll get a positive number for my second derivative. So if I'm looking at my double prime chart, I want to know where's f concave up. It will be in this section right here. So it is concave up on the interval 0 to infinity, and that is because f double prime is positive. Alrighty, 17. The rate of change of the number of people standing in line for Thrilling Thunder is given by r of t equals 4t squared minus 3t minus 7 for the interval from 0 to 10. Write an integral expression that gives the change in number of people in line during the time the number of people standing in line is decreasing. So we have lots of stuff going on in this problem, so let's see if we can just figure it all out. Okay, it does say to write an integral expression, so if my answer does not have an integral in it, I did something wrong. Okay, I do notice that the rate of change in the number of people standing in line, that would be people per hour. So that's a rate of change. All right, and then it says I just want the change in the number of people, so I just want to end up at number of people. So I am certain that to get from people per hour to people, I'm going to take the integral of this curve. So it's going to be the integral of r of t, or you could write it as the integral of 4t squared minus 3t minus 7. Okay, so I've got my integral expression. I just need to figure it out. It's not from 0 to 10 because it says find it during the time the number of people standing in line is decreasing. So if the number of people standing in line is decreasing, my rate would be negative. So I need to figure out where is r of t negative. So to do that, I will graph r of t, and I will find out when I graph r of t that at 1.75 the graph was negative and then it turned to positive. And I don't have a specific picture of what that looked like, but I do know that that's what's happening. So when I have that, all I have to do now is it's just going to go, that was the time period, so from 0 to 1.75, that's when the number of people standing in line was decreasing. So it's going to go from 0 to 1.75. I should have a dt to let people know my variable is t, but that's it. Right, number 18. The velocity in feet per second of a particle moving along the x-axis is given by the function v of t equals 3t plus 2e to the 2t. What is the average acceleration of the particle from t equals 0 to t equals 2? Okay, it says average acceleration, so I know I'm going to use the formula 1 over b minus a times the integral from a to b of my function. All right, so this is for sure going to be 1 over 2 minus 0. The integral from 0 to 2, and it's the average of whatever it says. It says it's the average acceleration, so I'm just going to put a of t right there. Notice I do not have a formula for acceleration. I only have a formula for velocity, but I do know that acceleration is the derivative of the velocity, so I can go ahead and find that, which would be 3 plus 4e to the 2t. And so now this is going to be 1/2 the integral from 0 to 2 of the acceleration, which is 3 plus 4e to the 2t dt. And then from here, this is a calculator problem, so I can go ahead and use my calculator to get that. That will be 56.598. Number 19, let g be the function given by g of x is equal to the integral from 3 to x of 3t squared cosine of t cubed on the interval 0 to 7/4. On what interval is g decreasing? Okay, if I want to know where g is decreasing, I need a g prime chart. And I do notice that g is equal to the integral, so if I took the derivative of both, the integral and the derivative are just going to cancel each other out, but remember we're going to replace the t's with x's. So g prime of x will equal 3x squared cosine of x cubed. All right, and we want to find out, we need a g prime chart for this. So I'm going to go ahead and graph g prime. So this is what g prime will look like if you graph it. Make sure you are in the right mode, which is radians. So my graph looks something like that. And we just need to find out, if I'm going to make a g prime chart, I need to figure out where does that derivative equal 0. So I'm again looking for the zeros on this one. And when I do that, I'll get 1.162. And then I'll also get 1.677. I notice that the graph is above the x-axis till it gets to 1.162, so g prime will be positive. It's below the x-axis till I get to 1.677, so g prime is negative, and then it goes back above after that, so g prime will be positive. And the question was, where is g decreasing? And so that would be in that interval. It's going to be in the interval 1.162 to 1.677, and that is because g prime is negative. Okay, problem 20. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared, y equals 4x minus x squared, about the line x equals 3. So let's draw a picture so we know whether we would like to use the shell, disk, or washer method. Y equals x squared is going to look like this. Whoops, I need to choose your calculator on this, so if you're not sure what it looks like, graph away. All right, this next one looks like that. So the area in question is right here. We would like to revolve it about the line x equals 3, which is actually the line right here. Since this is a vertical axis of revolution, we will be using the shell method. So when I use the shell method, it's going to be volume equals 2 pi from this x value to this x value, which will be 0 to 2. And if you're not sure, you could use the intersect feature of your calculator to get that. Since I'm rotating it about the line x equals 3 instead of x right here, it will be 3 minus x. And then we'll always do, for the height, we'll do top minus bottom. So the top curve is 4x minus x squared minus the bottom curve would be x squared. And at this point, feel free to use Math 9 on your calculator. I just simplified it one step before I did that. So I used 4x minus 2x squared. And then from here, you'll be using Math 9, and you'll get 33.510 as the volume.